Okay, so we're going to title this lesson 2.1b. So we did 2.1 yesterday, so we can think of yesterday as 2.1a. So we're going to call today 2.1 part B. Okay? 2.1b. Remember yesterday we were graphing a parabola. We used opposite of b over 2a to find the vertex. You guys remember doing that? Okay? You had 4 practice problems to do for homework yesterday. I hope those went well. Today we're going to talk about another way to graph. Do you guys remember in Algebra 1, you could graph in y equals mx plus b form, right? Or you could graph in ax plus by equals c. Do you guys remember standard form? Seen that? You had to change it around a little bit, right? But you could still go from either of those equations. This first one was easiest because you already had your m and your b, right? If they were giving you this equation, you would have to move it around. You guys remember that from Algebra 1? Same case here with parabolas. You don't need to write that part down. That was just for reference for you. Okay? So same thing here with Algebra 2. We first gave you, let's write standard form, y equals ax squared plus bx plus c.
I think that was my intercept form.
That's standard form. Intercept means that it's slope-intercept, that there's only one exponent. How many exponents are up there? 2. So we're graphing quadratic. So that's called standard form of a quadratic. Okay? So there's standard form of a linear equation of a line. This is standard form of a quadratic. So we talked about standard form yesterday. Remember we had to do opposite of b over 2a. Does anybody remember what 2 letters we used for the vertex? Mitchell? H and K, right? We talked about H and K. Okay? So today, they're going to give us the easy form, which is called vertex form. We call it vertex form because they give you the vertex. Here's your H value. Here's your K value. So H and K are going to be obvious to us in the equation. So the equation's going to look a little bit different. Notice, though, that it's still squared, right? So we still have a parabola shape. They just are giving us the equation in a different form. So when we have to find our vertex, we have to be really careful about the h value. The h value is going to be the opposite sign of h. So let's write that. Opposite sign of h, so that you remember. For example, if my vertex was negative 2, 3, don't write this down, just watch. If my vertex was negative 2, 3, okay, so this would be my h value. When I put it into my equation, it says x minus whatever your h value is squared. So if my h value was negative 2, what do you notice about these 2 signs then? Minus and minus turns into what? So then it's going to look like x plus 2 squared, but what was it really? It was really that negative sign, right? But because the equation says minus whatever your x value is, you have to be really careful about that. So it's going to be the opposite of our h value, all right? So if we wanted to convert this back into standard form, we would use multiplication, and we're going to do that in our next lesson. So try multiplication here, but we're going to do that in our next lesson. So let's identify our vertex in number 1. Here's my h value. Here's my k value. Right? They're giving it to us in the order. So my h, is it going to be negative 2 or is it actually positive 2?
Positive.
Good. We always do the opposite sign of h. So our vertex is positive 2, 3. What's the axis of symmetry? Remember how we find our axis of symmetry?
Positive 2.
Because we know the x value of our vertex is the same as our axis of symmetry, right? Mm-hmm. So this is going to be x equals 2. That's that imaginary line. Now, is this going to open up or down?
Positive.
What's positive? What are we looking for? What did we look for yesterday in standard form? The a value. Look in your formula. Do you guys see the a is right here in front? So in front of the parentheses, what number is really right here if I don't see it?
An invisible 1.
An invisible 1. Good. And that's positive, right? So we know that this is going to open up. If it opens up, does it have a minimum or a maximum? Minimum, right? If it opens up, it has a bottom, right? There's your bottom, your low point. So this one's going to have a minimum. When it's in vertex form, we don't go for the y-intercept because that's going to take a little bit more work, so you don't have to do the y-intercept. But what we are going to do is our domain and range, which is new to us now. Okay, so let's go ahead and plot our vertex and our axis of symmetry. We're not going to worry about this little table over here. So our vertex is at 2, 3, over 2 on our x, up 3 on the y. Remember, we label it. We have our axis of symmetry, which is our dotted imaginary line going through it that has arrows on the ends. And then what do we need to write on our axis of symmetry? X equals 2. And you can write it below it if you want to. We said this parabola is going to open up. So we're going to do a rough sketch of this one opening up. Please make sure you have arrows on the ends of your parabola, Dalton. And anybody else that doesn't.
I knew she was going to say.
Just a rough sketch. It doesn't have to be perfect. Just make your parabola open up. So now we're going to talk about your domain and the range. Does anybody remember what domain means? All the x's, right? And then your range is all of the y's. So if we're thinking about our domain here, this one's kind of hard to visualize, okay? So it's asking us which x values does this parabola touch? Well, we can see right now, let me get like a yellow so you guys can see it. Or blue, that will work. Okay, do you see that when x is here, okay, then it touches it on this parabola. The 4 value touches it up here, the 7 value is going to touch it up here, the 0 value is going to touch it up here. You don't need to do this. Do you see how the x values are going to touch all the way across? You guys see that? And isn't it true about the what's the point of the arrows?
That it goes forever.
That it's going to keep going forever. So if you look at Miss Carolyn, she's doing this. She's not just stretching. Your parabola is going to keep going on and on out forever. That's what the arrows mean. So eventually, you're going to get all of these x values all the way across the entire x-axis.
Now how
Eventually, that will happen. Why does that happen? Because your parabola continues to go up and out the whole time. Up and out, up and out, up and out, up and out.
And now how will you get the value of the x value then?
So we're not going to try to find those. We're just trying to see that our parabola is going to eventually stretch that whole x-axis. Eventually. We're not going to be able to draw that and capture that. Okay, but that's why we put the arrows on it. Okay? So what this means is our entire x-axis will eventually be somewhere on this parabola. Okay? So we're going to say that the domain is all the values from negative infinity to positive infinity. So that's going to stretch the entire x-axis. So your domain is from negative infinity to positive infinity. Negative numbers come first, so your negative infinity needs to come first to positive infinity. It's just a sideways 8 where you can draw 2 circles next to each other. Okay, let me back this up, and I want to talk about your range here. So at 2, 3, okay, we already talked about our domain. What is our lowest y value, though? If we're thinking about the y values, if I think about this negative 2, is it touching the y-axis anywhere? What about at 0? Is it touching the y-axis anywhere? What about at 2? Is your parabola touching the y-axis? Where does your parabola start touching the y-axis? At 3. right? That's the lowest that the parabola comes down to on the y-axis is 3. Okay, so our range is going to be from 3. Now look, I used a bracket. We're going to talk about that a little bit later in a couple lessons, but a bracket means you include it, because 3 is an answer there. And where is your parabola shooting off to on the y-axis? What's way up here on your y-axis? Infinity, right? Your parabola is going to continue to rise, and it's going to go all the way up to positive infinity. We can never cap infinity, so we always use a parenthesis when we're talking about infinity. Again, we used a bracket to represent equals. Do you guys remember when you were doing inequalities, you did an open circle or a closed circle? Do you guys remember that? That's the same thing as a bracket and a parenthesis, okay? Bracket means a closed circle. You can include it. A parenthesis means it's like an open circle, okay? Any questions on example 1 before we go on to example 2? Okay, let's find the vertex of example 2. So remember, you just have to look at it. We don't even have to do any math here. You're just looking at it. Okay, so is it going to be positive 3 or negative 3? Negative. Good. Negative 3. And is it going to be positive 1 or negative 1? The k value stays the same, okay? So here's my h and my k. Negative 3, negative 1. What's our axis of symmetry here, Leanna? Not just negative 3. There we go. X equals negative 3. Is this going to open up or down, Crystal? What do you think?
Up.
Why do you know that?
Because the number is negative and therefore it's going to be a frowny face.
What number is negative?
Down.
You're looking at which value to tell me whether it goes up or down.
Oh, excuse me, I'm sorry, it's positive.
It's positive. The a value, which is 2, is positive. So it's going to go which direction, Crystal?
Down.
If it's positive,
Up.
there you go. Yep, it goes up. And we said if it's positive, it has a minimum. Okay, so let's go ahead and graph it. The negative 3, negative 1. You're labeling your vertex, negative 3, negative 1. Your axis of symmetry goes through it. And then we're going to do a rough sketch of it opening up. What do you think about our domain? Doesn't this graph look very similar to the one in number 1? Okay, and the domain covered the entire what? The entire x-axis. And doesn't it look like this is still going to be the same thing? Right? So the domain is going to cover the entire x-axis. So your domain is going to be negative infinity to positive infinity. Don't forget to label your vertexes.
So does domain ever, is domain ever anything but negative or positive
Oh,
infinity?
interesting question. Let's see what happens on number 3. Okay, what about our range? What's the lowest that our y value goes to? Be careful, on our y-axis, the lowest that it touches is negative 1, right? And so then we're going from negative 1 all the way up to infinity. Good. Questions on number 2? Ooh, good catch, Olivia. Olivia said, aren't we supposed to put that in a bracket? Yep, because it is touching negative 1. So negative 1 should be in a bracket and infinity around the parentheses. Okay, let's try example 3. Oh my goodness. So number 3, what is going to be our vertex here? Someone who I haven't heard from today. Alyssa, give it a shot. What do you think your vertex is going to be? What's the h value of your vertex, the first value? Remember we label it like this? Yeah, good, 2. And it's going to be positive 2, right? Because we always do the opposite sign. What's the k value then, Alyssa?
1.
Good, perfect. Okay, what else do we know? Rebecca, what's the axis of symmetry? Perfect, x equals 2. Kate, is this going to open up or down? Cade, is this going to open up or down? How do you know? Okay, this right here, this a term is negative. So the number in front of the parentheses is a -1, so it is going to open down. And if it opens down, it has a maximum or a minimum, Dalton? Good, a maximum. Okay, let's go ahead and graph this. Make sure you label your vertex. I want you to label your vertex here, with a V. See how I did it up there? Put the little V21. You see it? Here.
Okay, thank you.
Okay. Our axis of symmetry, always going through the vertex. And this time it's going down, so we're just going to make a rough estimate of it going down. Remember, it should be a U shape, not a V. Okay, let's talk about our domain. Is this parabola eventually going to stretch the entire x-axis?
Yeah. Yes.
So what Crystal suggested in the last problem, that your domain is always -infinity to +infinity, do you think that she's right?
It's probably going to be reversed in this case.
Is our parabola going to stretch the entire x-axis eventually? Even though it's going down, it's still spreading out, going down.
No, because it's going towards negative, not the positive.
Okay, but we got to think about the x-axis right here, right? Am I going towards? Eventually, I'm going to hit all of these x's on here, right?
Yeah.
Eventually, I'll hit all those x's. Okay, so your domain is always going to be -infinity to +infinity until you get to pre-calculus. But we are not doing pre-calculus when you do hyperbolas. Is that what those are? The sideways one?
The domain will always be -infinity to
Yes,
+infinity
yes.
until we get to what the things don't matter right now.
Correct. Yes. We will not do that in this class. Yes. Okay, now let's look at your range value. Let's look at your range value. I kind of messed this up, but what is, now this time, what's the highest point it's going to get to on your y-axis? 1, right? You guys see that? But 1 is the highest value. What's the lowest value that it's going to? Good, Rebecca. It's going to -infinity, right? So when we write our range, we always write it from small to large. So our range is -infinity to 1 with a bracket. So make sure you write it correctly. We always write it small to large, so we kind of have to think about it backwards. Lexi? If it's a number, it's always going to be the bracket. If it's infinity, just think of it that way. Because you're going to, there is actually a point on number 1, on point 1. Okay?
So how is a -infinity a less number than a positive number? Because if it goes infinitely, that means it's infinitely larger.
But it's infinitely negative. What's smaller, -100 or -10? Which one's smaller? -100 or -10?
100.
Right. So the bigger the number in the negative zone, the smaller that it is. Right? Kind of backwards a little thinking. Okay, any questions on number 3?